Good morning, algebra class. Today we are talking about solving logarithmic equations. Yesterday we were solving exponential equations. Today logarithmic equations, and maybe you can guess how we're going to do that. Yesterday we took our exponential equations and we converted them into logarithmic equations, and that helped us solve them. Today we're going to be doing that the other way around. Let's first take a look at a couple of questions that don't require us to do a whole lot of changing and converting. Let's take a look at the kind of question you may see, which is log of 5x plus 1 equals log of, let's say, 2x plus 7. Okay, now those are both logs. They're equal logs. They both have just logs on either side of the equation. They don't have anything added to them. They don't have anything squared, or they have nothing that really hinders us. Basically, it's a common log of this equals a common log of this. Well, intuitively we know if they are equal logs and these two quantities are the only thing that they look different, they're two different expressions, they have to be equal for the two logs to be equal. All I need to do here is say 5x plus 1 equals 2x plus 7 and solve that from there. So I'm going to do that. Just subtract 2x from both sides. I get 3x plus 1 equals 7, and then I subtract the 1 and I get 3x equals 6. That means x equals 2. Okay, we've solved it. Now, they're not always going to be that easy. So when you come across something where you don't have a log equal to a log, where you can just set those two quantities equal to one another, let's talk about how you go about solving that. So let's look at something like this. Log of 3x plus 1 equals 5. Okay? Now, this one is a little bit different because it only has one log, all right? However, if I see something where I have a log equals a number, I know this part that has the expression, I can change this into an exponential function and not have that expression be part of that logarithmic function anymore. Let me show you what I mean. This is log base 10. I can change this from log base 10 of 3x plus 1 equals 5 to 10 to the 5th equals 3x plus 1. Remember how we do that. We take the base of the exponent is the base, or the base of the logarithm is the base of our exponent. We go across and get the 5. We come back over and we get that 3x plus 1. So this is 10 to the 5th equals 3x plus 1, which is something that is much easier to solve, okay? So this means that I've got 5 5s going after this equals 3x plus 1. Oh, did I do 5? Yes. So now I'm going to subtract that 1 from both sides. Now I'm going to divide both sides by 3. And I've solved the equation. So the way that I do this is simply that I need to change it into an exponential equation. Now, some of them are going to have a little bit more involved. They always get more complicated. So let's do one that's a little bit more complex. Let's do okay. Now, this one has not only a log in it, it also has something added to that log, but that's okay because I can move this to the other side. And actually, I'm going to change this because technically that would not ever happen, what I just wrote there. Let's make that a minus. Log base 3 of 2x minus 7. That minus 7 is not part of the log because it's not part of the log, I'm going to make it go away from this side, from the left side. I want it gone from that side. Otherwise, I can't change it into an exponential function. So I'm going to move that or add it to both sides. Okay? And I get log base 3 of 2x equals 10. Now I have a log that I can then change into an exponential function because it's on one side by itself and equal to a number. So I can say 3 to the 10th power equals 2x. Okay? So 3 to the 10th power, I don't know what that is, but let's divide out that 2 first. So we get 3 to the 10th power divided by 2 equals x, and we can grab our calculator and do that from there. So let's do 3 to the 10th power divided by 2, and we get 29,524.5 equals x. And that is how you solve logarithmic equations, by converting them and changing them. Now, in your homework tonight, you're going to have different kinds of equations like this. Some of them you will have to do some alterations. You'll need to either divide. Maybe there's a number in front over here, in front of that log, that you'll need to divide out first. Or there's a -7 like this one. We have to move that to the other side or add it to both sides so that we have just a logarithmic expression on this side. So if you have any questions, let me know, and I will see you soon.